Hi, this is the next video for the Year 2 Pure. We're looking towards exercise 11b. Now, this is where we need to be all over the chain rule for differentiation. Let's go straight in to example 3. So I want to integrate cos of 2x add 3. Now what I need to be saying is what differentiates to give cos of 2x plus 3. So I'm going to try to differentiate something to get cos of 2x plus 3. Well, I know that sine differentiates to cos, so I'm going to attempt differentiating sine of 2x plus 3. Now we know that sine goes to cos, so chain rule says differentiate the whole thing, multiply by the derivative of the bracket. So you need to be comfortable that 2 cos 2x plus 3 is the derivative of sine 2x plus 3. If you're not comfortable with that, you need to go back to the differentiation, look at the chain rule and understand how I've done that differentiation, otherwise you're not going to be able to do the rest of this chapter. So what I'm saying is, what's the integral of this, or what differentiates to give cos of 2x plus 3? Well, I've found something that differentiates to give 2 cos of 2x plus 3. Well, that's twice as big as it wants to be, so I'm just going to halve sine of 2x plus 3. So a half of sine 2x plus 3 plus c. So if you like, I'm integrating by considering the differentiation of a function. E to the 4x add 1. Well, what should I try to differentiate? I know that e to the x differentiates to e to the x. So let's see what happens if I differentiate e to the 4x add 1. Well, the chain rule gives me e to the 4x add 1 multiplied by the derivative of the bracket, which is just 4. Well, that's nearly what I want, but it's 4 times too big, so I can just fix it with a constant. So there we go. So because I know that e to the 4x add 1 differentiates to 4e to the 4x add 1, I know that a quarter e to the 4x add 1 differentiates to 1 e to the 4x add 1. Okay. Sec squared 3x dx. Well, looking at the results, the standard results that I'm given in the formula booklet, I know that sec squared is the derivative of tan. So I'm going to attempt to differentiate tan 3x. Chain rule again, tan goes to sec squared, differentiate the whole thing and multiply by the derivative of the bracket. So that's 3 sec squared 3x. Again, I can fix it with a constant. So I've done the integration, if you like, by differentiating, by considering what was it that I differentiated to get the expression that I have. Okay, all of these work because I just need to divide by a constant. This only works if it's a constant that you need to divide by. If you need to divide by a function of x, it's not quite the same thing. So in general, if I know that I have, if I know that I'm trying to integrate a derivative of something, so if I know that what I'm trying to integrate is a derivative, I've used the chain rule, then I differentiate my function, divide by the constant, not forgetting the plus c on the end like I nearly did. Example 4. Okay. 1 over 3x add 2 dx. Well, I know that the derivative of log x is 1 over x. So I'm going to try to differentiate the derivative of I'm going to try to differentiate log of 3x add 2. Chain rule says 1 over 3x add 2 multiply by the derivative, which is 3 over 3x add 2. Well, that's 3 times 2 big, so the integral must be equal to a third of log 3x plus 2 plus c. Now often in the book you see it written as, you see the 3x plus 2 inside a modulus operator, and that's because of course you can only take the log of a positive number. So that wouldn't lose marks, but I guess that's more technically correct. Okay, let's try 2x plus 3 to the 4. Well, I know sort of what differentiated to give that. I'm going to attempt to differentiate 2x add 3 to the 5, because of course when you differentiate you reduce the power. There's going to be some constant to fix it with, but that's fine, we can fix it with a constant. Differentiate the whole thing, bring the power down, reduce the power, multiply by the derivative of the bracket, so 10 2x plus 3 to the 4. Well, that's 10 times 2 big, so my integral must be a tenth of 2x plus 3 to the 5. The nice thing about these videos, of course, is you can pause and rewind and get your head around this at your own pace. But it is critical that you can understand where these have come from, how I've chosen what it is that I'm differentiating, and after a while you can do this stuff in your head. Okay, have a go at 11b. Enjoy yourself.